Hello, website viewers that are pretty much viewing my website. I have done this tutorial twice, but my microphone was off one time. It didn't work the other time, so I just used the microphone from my computer. Actually, there was two other mistakes. So you know what? I can be stupid sometimes, but it doesn't really matter. So obviously you're here to learn about binary code, and I'm just going to teach you 0 equals off and 1 equals on. Okay, and if you look here, this 0 right here that my little line thingy is hovering over, that equals 1, the second 0 equals 2, the third 0 equals 4, the fourth 0 equals 8, this 0 equals 16, 7th 0 equals 32, or yeah, or the 6th 0, and then the 7th 0 equals 64. That's pretty much the base of what you need to know. So to write 0, you just leave everything blank, right? Because it's obviously going to equal nothing, okay? And from 1 through 3, you're really going off the first two numbers. And then 1, okay, you just need to turn the last one on because it equals 1, 2, 4, 8, 16, 32, 64. And then you need a higher bit number to do any higher. And I'm just going off 8-bit because 16-bit would take too much time. And then 2, you just need to turn the 2 on, right? Because it's 1, 2, 4, 6, 8, 16, 32, 64. Okay, for 8-bit. So then you turn that 2 on, right? And then how do you get 3? You just put the 2 and the 1 together, and bada bing, bada boom, you get 3. And so I broke it up like that so that this extra number right here is going to be from for numbers 4 through 7. Sorry, that was a bit loud. For number 4, remember 1, 2, 4, so this one you just need to turn 1 on, and then right here for number 5 it's going to be turn the 4 on and then turn the 1 on, and then you'll have 5. Okay, so 6 you just need to turn the 4 and the 2 on. So if you look at it like this, 4 plus 4 right here plus 1 equals 5, and then 6, so it'll be 4 plus 2 equals 6, and then here it'll be 4 plus 2 plus 1 equals 7. See how that works? Should be catching on now. 8 right here, like I said earlier, 8 is right here, so 8 and then it's 0, 0, 0, so you see how that works. Then 8 right here is what that 1 represents, and then just add the 1 on, so 8 plus 1 equals 9, and then 8 plus the 2 right here equals 10, 8 plus 2 plus 1 equals 11, and then 8 plus 4 equals 12, so now you should be catching on, or you better really be catching on. And now you have the 8 plus the 4 plus the 1 equals 13, and then you have the 14, which would be 8 plus 4 plus 2 equals 14, and then you have the 8 plus the 2 plus or 8 plus the 4 plus the 2 plus the 1, and so the 8 plus the 4 equals 12, and then plus the 2 equals 14, then plus the 1 equals 15. So then etc, etc, you just take this 0 right here, add a 1, that would be 16, and then you go 0, 0, 0, and then you add a 1 here, that would be 17, then add this one here, take this one out, it would be 18. So it's really just multiplying the end, or the beginning part of the numbers, and then adding the end. So, or doing the multiplication, knowing what this number furthest to the left is, and then adding as you go on. So, knowing their values really is all I need to know. Lowercase letters, it's quite simple. It's just like the numbers, but there's just a slight twist here. As you can see, there is 1s right here. It's like, what the heck do these 1s mean? Like, what am I going to do with these? It's the same exact thing, okay? Turn this 1 on here, but you do need these 2 1s. If you don't have these 2 1s on, you're pretty much not going to get a number, or you're not going to get a letter. You're going to get an uppercase letter. If you have this one right here off, but you have this one here on, you're going to get an uppercase letter. So as you can see, it's the same as the numbers. You add that 1, then you go here, you add what would be a 2, 1. So it's pretty much like the way the letter is in the alphabet. So since A is the first letter, is going to represent 1, but with the lowercase symbols, which would be these 1s right here. Then B is the second one, so you put the number 2. And then C is the third letter, so you put what would be equivalent to 3. Then D is the fourth letter, so you would put what's equivalent to 4, and then etc. etc. So as you can see what I'm saying, so like E would be equivalent to 5. So like A equals 1, B equals 2, C equals 3, D equals 4, E equals 5. So then you would put the 1 for 4 and then the 1 for 1, and then you would get 5, which would be equivalent to E. You just gotta make sure you add those 2 1s at the end. So that's how the lowercase letters work. You know, like the numbers, if you can learn the numbers, you're pretty much set for the lower and uppercase letters. Symbols gets a little confusing because I haven't really found a trick to learn them, unfortunately, and there might be a trick just right in front of my face. So here, you don't need to add the extra 1 here. It's just 1 1 0 1, not 0 1 1. And then you put here, so A is the first letter, obviously, so you put the 1. B is second, so you put the 1 and then the 0. And then etc. etc. You know, just like the lowercase letters, except you don't add the additional 1. You just keep one regular 1, not 2 1s. That's how you do uppercase letters. I'm going to make a new page, and I'm going to show you that this is off of pure memory and knowledge, not off of me just copying off of a bunch of cue cards or something like that, you know, because, you know, anybody can teach a class, but they obviously don't know what they're doing. So, let's say I wanted to write the number, I don't know, 57, okay, so 1, 2, 3, 4, 5, 6, 7, 8. It should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it should be 8. Okay, so to write 57, we just need to do a little multiplication kind of trick. So we need, that would be 1, 2, 4, 8, 16, 32. So we delete this one because 64 would obviously be above, wait, no, wrong one. 64 would obviously be above 50. Oh crap, that is wrong. Okay. 64 would be above 57, right? So you can't put the 64 there because obviously the value is already higher. So now we have 32, right? And then the next value is 16. So that would equal 48, correct? Yes, I am right. Yes, 48. So we put that number there. And now we need to find 11 more. So what would we do? We have the 32 and the 16 on, so we can't put those on anymore. And then now we have the 8, the 4, the 2, and the 1. And since we need 11, let's put that one on. Let's put this on. So now we have the number 56. Let me think. Yeah, 48. That would be 56. Now we need to find 57. So we just go over here. And we would subtract or take away that 0, and we would add the 1. So now we should have 57. I'm going to go onto an online converter, and I will also include this Word document in my downloads page on my website so that you can use this kind of as a guide. So give me a minute. I'm going to pause, go to the website, and then I'll show you, or we'll see if I'm right. Okay, so if you wanted to see if I cheated, you can just look at the time. I mean, like, obviously it's still there. So now we're just going to check. So it's going to be 1, 0, 0, and then 3 1s, and then stop at the other 2 zeros. So let's see this. So 0, 1. Okay, so now we need to move. Okay, so now let's just go here. Right here. 1. Wait. And there you have it, 57. Okay, obviously I just wrote that off the back of my head. So, you know, anybody can learn it. You know, it's not the impossible. Everybody thinks that code and binary and C++ and C and JavaScript and Python and all those other languages out there are impossible. I suggest you start with binary though. It's probably the easiest language to do. And it's, again, the base, you know. So I hope you enjoyed this. I like doing tutorials. Rendering time takes a while. I hope I have my website up with all the new updates by the time I promised I said I would, with the rendering time on YouTube. But anyway, I will see you later. Bye.